Good morning, everyone. My name is Julian Skeels. I am the Chief Digital Officer of Expereo. Expereo are a leading global network as a service, managed network as a service business. We work with about 60% of Fortune 500, connecting them in over 190 countries and around the world. And I'm very proud to represent Expereo here as the sponsor of the digital transformation stage in this beautiful venue. Although I'm very aware there's a pigeon flying around here somewhere, so I'm trying not to be used as target practice. So for today, I'm going to talk about an often overlooked part of digital transformation, because at the center of many companies' digital transformation is their use of AI. AI being a foundational piece of their technology strategy to deliver a digital transformation. Now, you're not going to be short of options over the next couple of days to attend talks about AI. And just over there is one right next to me. But hopefully this one will give you a slightly different perspective. This is not just another vendor AI talk. I'm not even going to talk about how we use AI to drive transformation ourselves. I'm not going to talk about models. I'm not going to talk about frameworks or tools. I'm not going to talk about even how you enable your organization to embrace AI. I'm going to talk about something which is maybe even a little bit less fashionable. Something that's been with us forever and often overlooked, but it's something that is as decisive to your AI future as any of those other things I've just spoken about. And that thing is your network. And in particular, global connectivity. In a world where AI workloads are taking place on the edge, in data centers, in the cloud, your global connectivity is a vital part of your AI strategy, because AI forces us to challenge some really long-held assumptions about our networks. And many of those assumptions are now wrong. And so if AI is to work at scale, if AI is to really work in the real world, then perhaps we've got to unlearn some things before we can learn new things. We're used to thinking about networks as being in the background. Historically, we've looked at them as binary. If they're up, they're successful. If they're down, it's a problem. Their job, move packets, get out of the way, passive, invisible. And that worked because in the past, our apps were often human initiated. A human being, no matter how effective they are, maybe is doing one or two high value things a minute at any one point in their time. But AI breaks this model, because in the world of AI, inference never stops. Retrieval never stops. Monitoring and remediation never stop. There is no idle state. There's no quiet period. Behind AI is millions and millions of micro decisions running continuously. So you cannot consider your network to be merely plumbing. Your network is now part of your AI runtime. It is a fundamental part of your AI tech stack. It is as important as the models that you choose. Because in the AI world, network failure is no longer just an IT issue. Network failure now represents real business failure. And one of the first things we maybe need to unlearn is our obsession in networking with speed. And for decades, we have learned that speed and quality are correlated. More bandwidth, bigger pipes, lower averages equals good. And again, that model worked when our apps were human-driven, intermittent, meaning that if they fail once, I just retry. And the next time it works, and I move on. But in the real world, AI doesn't just fail because data is too slow. In an AI world, real success relies less on raw performance and more on how predictable and governable the system is while it runs. Does it behave consistently? Can you see what is happening at every part of your network? Can intervention happen in real time? And many CIOs that I meet tell me they have connectivity everywhere. What they have is visibility nowhere. And in an AI world, sometimes slower but certain is better than fast and erratic. And here's a real example. This is two real-life WAN links. They are the same spec, same access technology. They both have the same 3 nines SLA of them. Same traffic profile running. They even have a very similar average latency. But that's where the problems start, because AI doesn't care about your averages. In the real world, high-scale production AI applications, what AI cares about is jitter, packet loss, latency measured not as an average, at the 90th, the 95th, the 99th percentile. And if we look at the spikes in this, which one would you choose? Would you choose the one that has silent decision degradation, which is what the graph on the left represents? Or would you choose stable inference? And this comes from being able to visualize and manage your network end to end. Not just the last mile, not just within your LAN, end to end, where the traffic starts to where it finishes, and having that entire experience observable and managed. The graph on the left is just a regular piece of last mile internet connectivity. Graph on the right is exactly the same connection, but with Expereo's proprietary BGP optimization running at Amazon. 3 nines as an SLA tells you nothing. Averages tell you nothing. Success of your AI strategy lives in production, and it fails in these peaks. No matter how good your models are, no matter how good your teams are, it fails in those peaks. And it fails in variance that was ignored. Variance that was ignored when it was designed and bought. And so if we're going to be honest with ourselves, we need to ask why these factors so often get ignored. And the uncomfortable truth is that when we relegate something as important as networking, and we treat it as basic plumbing, we treat it the same as we do water or electricity, and we undervalue it, the uncomfortable truth is that these networks were not optimized for real-world applications. They were optimized to make it easy for procurement teams to buy them. Standardized contracts, comparable bids, clean SLAs, best value. None of those things are irrational. But there's big consequences when simplicity for procurement defines the production architecture that engineers are going to have to live with. So rather than simplicity of procurement, we need to be thinking about performance criteria, resilience engineering, understanding how these things behave under real production stress, and then buying the right thing in the first place. But why do we make these mistakes? We're not, procurement teams aren't bad people. They're using their best intentions. And I think it's this. I think it's that humans take false comfort in things. When a vendor tells you something is always on, when they can point to an SLA as an insurance policy, well, an insurance policy is not a hard design principle. It's a reporting mechanism that describes the past. It can't predict or it can't prevent the next failure because AI doesn't fail cleanly. It degrades quietly through brownouts and missed signals and late decisions. And all this time, your SLA dashboard is going to be green. It's going to tell you everything is fine, while your AI strategy is failing. So always on is not anything a single vendor, provider of last mile connectivity can promise you. Always on has to be engineered. And it has to be engineered through path diversity, technology diversity, real-time detection, but more importantly, real-time remediation as well. And that's not something that's only promised in an SLA. It's something that has to be designed and engineered from the start. And AI is challenging us in other areas, particularly security. In a world of AI that removes quiet periods, that also applies to attackers. Continuous, automated, and at machine speed. So security now, it has to be enforced in the data plane. And importantly, it has to be enforced in real time. If security assumes that you can inspect first, it's too static. If it assumes you've got time to analyze later, it's too slow. You haven't got time. And many organizations are investing in technologies like SASE to converge their networking and security, and that direction is broadly right. But AI is raising the bar of what you need from your SASE platforms. The expectation can't just be identity checks that bog it. It can't just be policy enforcement on the edge. It now needs to be continuous. It now needs to be driven in real time in the data path continuously, combining identity, policy, performance, and risk that can adapt as conditions change. And if your chosen platform cannot adjust in real time as the traffic flows, it's enforcing security models that will not survive in an age of AI. In the AI world, your network path is your security surface. And here's why this really matters, is that I believe that in real-world production AI, one of the biggest risks is you don't even need a bad actor to break your model. You don't have, your problem is not even so much, maybe even data leakage or something like that. You just need somebody that can affect one scale decision to cause a disproportionate impact to it. A manufacturer using computer vision to make thousands of micro decisions every second about things coming down the production line. A factory using autonomous robots that are doing real-time discovery to avoid a safety issue. A bank using AI for purchase approval decisions. Just degraded network latency on one of those calls means that inference responses slow down on production lines. Autonomous vehicles go into a safety mode because they're not getting the response fast enough. Thread pools build up and asynchronous pipelines collapse with excessive queuing. In high-scale AI, latency is like the butterfly effect. A few milliseconds here, small bit of variance there, quietly introduced, cascades through retries, through timeouts, breaking control loops, and scaled across thousands of decisions every second is real impact. Machines stop, payments fail, factories slow. But all this while your SLA is still green. And if we're really going to obsess about the integrity of every single decision AI is going to make, we need to obsess about where that data flows as well. So we have to reframe how we think about sovereignty in an AI age. We tend to think of sovereignty as being a data at rest. It worked for static systems, but AI is breaking this because the core of AI is about data in motion. It's about context pools, service calls, real-time feedback, with real decisions shaped by these flows and the paths that data take and the jurisdictions that data flows through, and who has control and who can influence that flow of data. Which bad actor, which digital nation state can add just enough degradation to cause real world problems. So if you can't fully observe and enforce the paths that your data is taking within your global connectivity, you cannot prove sovereignty, no matter what any platform vendor will tell you. You cannot prove sovereignty. All you have is paperwork, nothing more. You do not have sovereignty. It's not a legal attribute. It is an operational capability. It's enforced at the network layer. It happens at the moment the data moves. So by now, the pattern should be clear. We see every day companies doing so many of the right things, using AI to drive their digital transformation. They're picking the right model. They're choosing the right tools. They've identified the right problems. They're enabling their organization to be AI native. And they can show you their AI in the lab and, oh, it looks brilliant. And they show it to their management, they show it to their board, they show it to investors. It looks wonderful. But it fails when it hits its first contact with reality. It fails when it meets the network. When decisions depend on continuous movement, latency, routing, policy. When security, sovereignty, performance merge in the real world. When all these hidden assumptions and poor design choices surface real. When in essence, a company's AI ambition outweighs their operational reality. But there are some positives. There are some really good examples out there. And when we look to the real leaders who are making a real impact in this space, what is it they do differently? They don't have better intentions. We've all got good intentions. None of us go to work in the morning determined to do the wrong thing, to do the bad thing. We all have good intentions. But they make different design choices. They design for behavior and data, not diagrams. Most importantly, they design for extremes. They ask themselves at every critical part of their infrastructure, what is the worst of this thing's format? And how would my system continue to operate at scale under those conditions? They don't design for averages. They obsess about observability. They measure everything, absolutely everything. And they are highly suspicious of anything they cannot see themselves, that they rely on some other party to tell them the truth. They can't see it, they can't measure it, they do not trust them. They bring network and security and sovereignty together as real policy, real controls embedded in the data plane. They do not rely on documentation. And I think this is the important thing. They treat their network as a living system. It's not static plumbing. It's something that has to adapt continuously. It's something that needs to be able to change based on workloads, changes in performance criteria, changing risks and constraints. And they build the ability of change as a fundamental part of their design. And so if there's one question I'd like all of you to consider taking back to your teams, challenging them on, it's this. Don't ask them, strip away the hype. Don't talk about models. Don't ask for a demo. Ask them this question. Can we move the right data to the right place under the right rules every time, predictably, and can we prove it? Can we fit all of these pieces together? And if the answer you get is yes, you have an enterprise capability. You have a fundamental piece of your digital transformation strategy in place. The cultural truth is if you cannot say yes, what you may have on your hands is just a science project. And that's not going to be enough. And this is where we'd love to have a conversation with you. We're on booth 149 next door. We would love to speak to you. We act as an operating layer between your AI ambition and the reality of networks. We translate your intent, your objectives, your outcome into real architecture. Designing systems that assume variance, assume failure. We industrialize the global deployment of these systems, and we operate it as a continuously managed system. We offer global connectivity, we offer last mile connectivity, but that's just part of what we do. We can offer you DIA, we can offer you LEO satellite, we can offer you fixed wireless access, but that's only part of the story. It's backed up by our infrastructure that delivers you deterministic middle mile. It takes care of all your workloads, your traffic, from the point of origin to the point of destination. Drop them off at the front door under a managed, controlled quality criterion. And we interoperate the leading SASE platforms to enable you to embed security into the data plane where it needs to be in the world of AI. Not just procured for you, not just installed for you, but operated all day and every day. So in summary, I truly believe that AI is challenging the role of our networks. Changes threat models, it changes how we look at sovereignty, and it exposes assumptions that we can no longer afford to keep if we want our digital transformation strategies to be successful. The organizations that succeed won't be the ones that have the best demos. It'll be the ones that redesign their networks for real-world applications that will survive their first contact with reality. Thank you for your time today. I hope you've gained something useful with this. I'm on booth 149 for the whole event. I'd love you to drop by for a chat. Enjoy the show.